what we're going to do now is we're going to talk about some of the things that you can do that are a bit more automatic. So what I would like for you to do is to create a new variable in your system, and you can name it whatever you want. I've called it my string just to make it simple for myself. And I would like you to put in a phrase of some kind. So I've used, "This is the time for all good men to come to the aid of their country," because it was what I used when I was in my typing class in school to learn how to touch type. And it's something that I'm quite used to seeing over and over again. But any kind of phrase like that, maybe "the quick brown fox jumps over the lazy dog" is something that you're more familiar with. And go ahead and run that so that my string is inside of your memory. Now, what we did before already is we tried to extract parts of strings. So of parts of lists. And the same thing happens when you try to find a part of a string. So if I type in my string, and again, it is case sensitive, and I type in 13 and I run it, I get C. Now that can be a little bit confusing or a little bit frustrating to a lot of people, because that means it is the 1, 2, 3 space 4, 5, 6, 7, 8 space 9, 10, 11, 12 space 13th character in the string. And that's because a string really isn't an object in computer programming. It's really a list that has been all joined together. It's a list of characters. So a T, an H, an E, a space, but it just makes it look nice when it's a string. But when you ask it for the 13th part, it doesn't know what words are. It just knows what characters are. So it will count to the 13th character. So what we want to do then is maybe we want the word country at the end. Now we could sit here and we could count 1, 2, 3, 4, but it's a fairly long phrase and we're not wanting to do that. What we want to do is we want to find out how long this string is, how many characters there are, so that we can count backwards, which is a little bit easier if we just want the last word. And the way you do that is using the function len. Now, len is short for length, just so that's in your head. I know that I'm saying len, even though it's length, but that's just my American accent. So inside the brackets, inside the function parameters, what you need to do is you need to type in the variable you want to measure. So my string, and if I run that, it tells me 70. So this all together has 70 characters. And because of that, I can now say, okay, I can get a better idea of what I want to pull out. Now, as I said beforehand, when you want to find a specific number character, all you have to do is my string and that character, and that character. However, if you want to have more than that, if you want to have a run of characters, you need to use this little marker here, which is the colon. And if I do this, 0 is where I want to start. I want to start at the T. And let's say I want to do the first 10 characters. If I run that now, I now get the first 10 characters. Now I know what you're thinking, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but don't we start on 0? So really that's character 9. Why is it going to 10? What the 10 is actually saying is not including 10. It's saying when you see the 10th character, stop and do not go any further. Do not actually include that last number. So what this really says is I want characters 0 through 9, not 0 through 10. It's looking for the space before the 10 starts. So if you guys already have your phrase in, you can have a practice with this. So for example, if I do 15, to 60, I get a much longer string of letters, again, from my phrase. Now, if you don't necessarily want to put a number in, you can actually leave the first one blank, and that will do it from the beginning. And the same is true the opposite way. So if I do 60 and then blank, that will do 60 until the end. So if you don't actually know where you want to start it, or you don't want to put the 0 or the 70 in, you can just use those blank characters. The other thing that you're able to do, if you're so inclined, is use negative numbers. So if I say I want to start at 1, 2, 3, 4, 5, 6, 7 characters from the end, I use a negative number in order to do that. And then I get the last 7 characters of my string. So all of these functions that I'm showing you right now that work on strings, they work just as well on a list. Now, rather than you using your 4 lists that you did beforehand, we're going to make a brand new list here that is going to be a lot more useful to you. So what you want to do is you don't necessarily want all of these different string characters to be their own thing. You want to have a list of the actual words. The time has come. So there is a function in, okay, hopefully that still works. I'll just rerun my string to make sure. Let's see here, print string. Yes, okay. So what I want to do is I want to turn this string of characters into a list of words. And Python has a built-in function for that, and it is called split. Now, split basically is splitting up a string of characters based on spaces. So it knows what a space is, a white space, and it will use that in order to split things. So what you want to do here, however, is not put anything inside of here like you normally would. Instead, you have to do something slightly different, which is to type in my string and then a full stop. And the reason that that is happening is because the split function, the program that we're running by doing split, is actually stored, it's kind of hidden inside of every string. So we're not running split on my string, we're asking my string to run split on itself. And you don't really need to know that, but it kind of explains why there's these 2 different formats for how it's being written out. Now, I don't want to just post this into our print. I want to actually save it somewhere. So I'm going to save it as my words. So now that we have this, so my words is going to be a list, and it's going to know it's a list because of the information it's given from this my string.split. So I'm going to print my words once it's done and run that. And as you can see, it's taken the string of all these different characters, it's tokenized it, turned it into individual words, and put it into a list. So now if I go to my words and I say I want the 3rd word to the 7th word, I can actually get just those words. I can deal with that information a little bit better than counting each individual letter. The thing that we did with length also works just as well on list. So the list of words I have is 16 words long instead of 70 characters. So hopefully that all made sense. You, of course, could create your own list individually, but this makes it a lot more simple. So if you write your sentence out, or if you cut and paste a sentence from a document that you're working on, you can, with this very simple function, turn it into a list of words that now you can do some kind of computational work on. And this is hopefully where this is all driving to. So just add a couple more on here. Okay. So now that we've created a list of words, it's very difficult to see, just as was mentioned previously, the idea of this coming up in this sort of bracket of strings. Sometimes you want it to give you a subsection of the sentence, but you still want it to be a sentence. So if I just do my string, so it's just available so I can see it. Okay. So there is a new function that I mentioned previously called join. And what join will do is it will combine all of the elements of your list together in a single string again. But again, you have to do this in a way that is computational so that you're not simply having to write each string individually. And in order to do that, you will need to learn about something called a loop. But if it's just for the whole string, what we can do here is the function join. And the list of words, it might be my words, or it might be a subsection of that. So I'm just going to do from word 3 to the end of my list. And again, we're going to have that beginning before the full stop. Now, here is the part that you get to decide what you want to do. Inside a pair of quotation marks, and it can be single quotation marks as well. It doesn't really matter. It's a string that you're creating. You want to put something in between these words. So let's say you want to just recreate it as a sentence. You would put a space in between those words. So take this space and join it, or put it between every single one of the words in my list between 3 and the end. And if I run it, you can see it does from the third word until the end of the sentence. If, for example, I wanted to do something where I wanted to get rid of all the spaces because I wanted to create this as a file name, I could do this. And it would turn all those spaces, all those words would be joined with underscores rather than spaces. If I wanted to turn it into Pig Latin, I could add a in between all of the words, anything that you're wanting to do basically in order to join this list of things back together. And if we remember that first phrase that we did before, where you had that first set of lists before where you had all these different objects, this would work exactly the same way. And if you don't put anything in between it, it will smush all of them together just like a normal string would if you don't have those spaces. So join can be an extremely useful function just for turning a list of tokenized words back into a single string of vocabulary. Okay, so let's say that you don't want to just turn it back into a string. Let's say that you want to do something more interesting with those words. Let's say you want to make a column of all those words so that you can use it in some sort of spreadsheet or some kind of table. For that, you need to have a loop because we're going to be asking it to do different things. So let's say we have our list of words. The time has come for all good men. And what we want it to look like is something like this. So our goal is it for it to go, the time has come, and so on our list going down. So hopefully you can see what I've done here is I want it to print the word, and then I want it to print a colon and a space. And then I want it to give me the number of letters that is in that particular word. So what I want it to do basically is I want it to do to print word, and we'll get back to that in a minute, plus colon space plus the length of that word. And if I try to run this now, obviously it has no idea what word is. It doesn't know what I'm asking it to do. But what I can do is I can create a command that says, for every word in my list, I want you to do this. And another thing I forgot to do is there is no carriage return or making it a new one. So I need to add that as well. And that is basically that backslash and an N, it says new line. So it's creating a new line to begin with. So what I want it to do is something very, very simple. It's called a for loop. And the formula for a for loop is just for x in y and a colon. And what you do is the x can be anything you want. It is a temporary variable. It will only exist for the 5 seconds it takes to run the program, and then it will disappear from memory. It's just a temporary variable. So I'm going to call this word, just so my head can kind of wrap around what it is. And the thing I want it to look in is my words. So all this is saying is for every word in the list of my words, I want you to do this. And you'll notice that I put a tab here, or 4 spaces. Everything that goes underneath the list of instructions needs to be in a tab. So let's see how this works. Okay, can only concatenate string, not integer. Okay. So this is a very important lesson. Now, what I've done here is I've said, take this word, which is a string, add this, which is a string, add this, which is an integer, and then add this, which is a string. And Python has come back to me and said, I'm sorry, when you use the little plus sign, I can only do strings. I can't do ints. So I need to turn this into a string. And all you have to do is basically, this will turn whatever inside of it into a string. And so I put this length of the word into a string. And let's try that again. There we go. So I actually probably didn't need this because it was being helpful. Yes, it was being helpful. Okay. So as you can see, it's now gone for every word in my list. The time has come. Print the word, the colon and the space, and then the length of that word. And if I go down here now and I tell it to print word, it does country, because the last thing that it did with the word word, the last variable it filled up word in was country. So that's just something to remember. That's kind of like a bit of scratch paper that's left behind. So you'll have to make sure you rename that or reassign that if you want to use that variable again. What's another interesting list we can do with our strings? Count the same words. Oh, that's absolutely perfect. That's absolutely what we were going to do next. So there's a couple of things that we need to do before we're able to do that, but that is a brilliant suggestion. So let's just move on to that so that we can do it well. So I'm going to make that come down here. Okay. Before I move on, I hope, is everyone happy with the ability to do for loops? The idea to turn, it's really just as simple as doing this in that. The same thing would be true for my string. Just to give you guys an example, if we think about how many characters, or it's going to do just every single character. And of course, every character is just going to be one. So that is the same functionality, works just as well on strings as it does on lists. Okay. So for loops are pretty easy. If you have to do anything in your research, that you have to do the same thing over and over and over and over again, as I often do with my research, I really do use for loops quite frequently because it just makes my life that much easier not to have to keep writing things over and over again. And if you think about if you used to do lots of mailing lists where you would have Word use an Excel file in order to create labels for all of your dozens and dozens of letters that you were sending out, that's all it was. It was a for loop going over variables. If you want to create a form email that you send to lots and lots of people, you can have your list of people's names, their jobs, their research questions, and you can have a for loop use those variables to create all of your dozens of form letters. And hopefully you won't have what happens to me quite frequently, where somebody has sent me a cover letter and forgot to change the name of the university they think they're applying to. Don't ever do that. Okay, so what we're going to do now is we're going to do if-then statements. Now, an if-then statement is probably the most common thing that you'll ever do in Python. It's basically the bread and butter of these types of programs. And it's pretty simple. It kind of makes sense as a logical statement. If something is true, then do something. So when we had our for loop, it didn't care if something was true or false or right or wrong or matched to any criteria. But given the assignment we've been given now to look for identical words, we have to use some kind of test. And to do that test, we have to use an if-then statement. So what we want to do is we have our list of all of our different words. But what we want to do is to get a list of unique words, words that only exist, or words, so we only have one copy of each word, even though the word to is in here twice. So what we need to do is we need to create a sub list. We have my words, if, and it's very, very similar to a loop. If word in my words, okay, so for word in my words. So this checks through every single word in your list. If word starts with M. Let's start with. Now, this isn't going to get us all the unique words, but it does give you a really good idea of how the if-thens start with. So if word starts with T, print word. So this starts with is one of the inbuilt functions that exists in Python. There are lots and lots of these, and I'm afraid there's no easy way to go through them all with you, but there are exhaustive lists online. But for this case, we're going to go with starts with. So any word that starts with T. So it's going to go through every one of these strings, and it's going to look for the lowercase letter T. And if that exists, if that's true, then it's going to print the word. And so if I do this, there we go. Time, to, there, and there. The and there. So that's how the if-then statements work. If you are able to do that, if, for example, here we go. If word length, if the length of the word is less than 3, less than 4, we'll say. So when we had our list of how long each of these words was, quite a few of them are more than 4 letters, quite a few of them are less. So if the length of the word is less than 4, print the word. And now we have all of the short words. So all of these kind of things are available to you. If you want to do greater than, it's this, less than, it's that. If, however, you want to do equals, and this is why I thought it was important to say that one equal sign, you have to remember that means a sign. If you want to see if something is actually equivalent on both sides, it is equal, equal. So it's just sort of a different way of thinking about it. But if you want to see if these two halves are identical, if the length of the word is equal to 4, is actually identical to 4, you need to have those two equal signs. And if I run that, now I only get the words that are exactly 4 characters long. So hopefully that gives you an idea of what you need to do if you want to create that sort of sense. So we did have it previously that if the word starts with T, then to print it. But now we're going to do something different. We're not just going to print the word, because if we print the word, we can't do anything with it. It's just kind of listed in our console screen. We want to do something with it. So we want to add it to a list. So what we want to do is at the top of this, we want to create a new list. So words starting with T. You don't have to make your variable that long. I'm just trying to be clear. And we want to make it a blank list. We don't have anything in it yet. It's just an empty list. Then what we want to do here, instead of printing the word, words starting with T, we want to do something with that list. And what we want to do is we want to append something to it. So when you're appending, it's important that you kind of remember that append means attach to the end of the list. It doesn't put it at the front of the list. It doesn't put it in the middle of the list. It puts it at the end of your list. And the thing that we want to append, we want to put into these brackets. So the word. So what this should do, hopefully, is it'll create a list that has nothing in it. It will then go through every word in my sentence. And if that word starts with a lowercase t, it will add that word to this list. And then what I want it to do is going back to the flush, to the side outside the for loop, I want it to print that list. Now you'll see that here there was this red squiggly line, and that means that I put loads of spaces here, but not actually put anything under there, and that was confusing it. So make sure that you don't have that red squiggly line. So yes, so create the list, fill it up with all the T words, and then print that sub list. And let's see how it goes. There we go. So now I only have a list that just has these T words in it. Now you'll notice that there is this idea that, well, what if I wanted this first the? And there are a couple of ways to do that. The easiest though is to do an or statement. So if the word starts with T, or the word starts with T. And you can do this with or and, or not, any kind of Boolean logic you want to. But in this case, we want or, because it can't obviously start with an and, both of these letters. So if I run this again, now we have a slightly longer list that includes that capital TH, the. So I'm just going to give you a second because I really do want to make sure that you attempt to do this instead of just watching me do it. Go ahead, do different letters, do different combinations of things. Ends with E, for example. If you wanted to use the and, you could do starts with T and ends with E. So you only get time and the. So go ahead and do that. So we'll move on to the next part, and we're moving ever closer to doing that list of duplicate words. So the next thing we want to do is we want to be able to see if something is in our list, whether or not it exists within our list. So my words, just so we have it here. So there we go. So it's a little bit easier to read. So if I look at this, I've got lots of different words. And let's say I want to know, if I've got this huge bit of text, does the word aid appear in it? Does that AID, does that word appear in it? Now, I could try to do all sorts of variations of starts with, ends with, things like that. But the easiest way to do that in Python is just to simply ask it, is it in the list? So if I say aid in my words, and I go like this, true, yes, the string AID does exist within your list of words. Remember, if I go like this with a capital A, false. It does not exist because it does not understand the difference between a capital A and a lowercase a. Now, again, there are ways around that using something called regular expressions, but for the moment, we're just going to use that with the capital A, or the lowercase a. So that's all it takes to do is to look for that word. So using what we've already done, we can actually create a couple of really interesting concordances, or rather lists of words, to see if there are any duplicates. So let's think about this first as a list of instructions, and that's the best way you should start any of your projects. So what do we need to do? Well, first thing we need to do is we need to go through all the words in my sentence. For each word, check if I have seen that word before. If not, make a 1. If so, add 1 to the existing number. And then when we're all done, print list of words and occurrences. Okay, so that seems like a fairly simple set of instructions, and that's how 99% of programming works. It really is just a case of saying, okay, if I had somebody who was really, really diligent, who would do exactly what I say and never ever make a mistake about what exactly I told them to do, but I had to tell them step by step by step, what would my instructions be? So let's try to translate these into some kind of Python code. So we know how to go through all the words in a sentence. So for word in my words, colon. And remember, you always need that colon to start the instructions for that. For each word, check if I've seen that word before. Okay, so how do we go about and check if we've seen that word before? Well, the best way of doing that is to create a list of all the unique words. So what we're going to do up here is we're going to create unique words and make that an empty list. And that is basically going to be the template for creating our concordance at the end. So if word is in unique words, check to see if the word has been used before. If it is, then what do we do? Well, okay, so remember, the if statements are always if it's true, not if it's false. So yes, if the word is in that unique words, we need to add a number to the existing number that's there. Okay, so there isn't any kind of existing number. So how do we do that? If the word is in unique words, we'll just leave that for the moment. We'll come back to that. If it's not, is where we use else. So if something is true, we tell it to do something. If it's not true, is what goes under else, in which case we will tell it to unique words, append word. So just to kind of, we've created this list of unique words. It goes through all the words in my words. It checks to see if that word is in unique words. And if it's not, we append it to that list. Now, the best way to do this, I think, actually is just to okay, that just makes it a little bit simpler. So if the word is not in unique words, so if unique words is false, then append it to unique words. Now, at this point, we can keep going. We can add more and more functionality to it. But really what we want to do is to make sure that this code is working correctly. So what I'm going to do here is I'm going to go print unique words. And it is not working. So let's have a quick check. Okay. There we go. Okay, so this is the problem of moving from Python 2 to Python 3. Okay, so for words in my words, if the word is not in, and you can see not in goes purple, so it kind of gives you a sense that this is a phrase that Python understands. In unique words, append it to the unique words. And as you can see, the time has come for all good men to come, but we already have the word come, so it doesn't add that. The aid of their country. So now we have a list of unique words. So what do we do with this now? Well, we want to create a list that has how many times that has come through. So how do we go about that? Does anyone have any ideas about how we could use this unique list of words and then add numbers to it for how many times it appears in this big phrase? So we want to use a for loop with a count function. So for word in unique words, because we're only going to use that list there, we want to print, okay, so we want to for word in my words. Okay, so this is called nesting. So for every word in here, for the, we want to go through every word in here. But we can't have this be the same in both. So we're going to say my word to make that slightly different. So if word equals my word, Word int is not defined. Okay, so what we're doing here is we want to go through every word in the unique list, and then we want to go through every word in our full list. And if the two words is the same, so the and the, if they're the same, we want to take this little counter that we've created called word int, and we want to add a number to it. And once we're done going through all of the words in my word, we want to print what that word was and how many times we saw it in that phrase. So if we go like this, we now see 000000001. And that is not at all what I thought was going to happen. So we're going to do a little test. And this is, I'm doing this kind of on the fly because I want you to see kind of the process for doing it and not just that there is a simple correct answer. So okay. There we go. Okay, so what is basically happening is that because I've asked it to go in a loop, it keeps overwriting what it's doing over and over again. So for the word in unique words, the, it goes through every word through here. And what the best thing to do is to basically do what I'm doing now, which is called troubleshooting, which is to put in little print commands to see what numbers are coming up to make sure you understand it. So these are coming up as a 1, and then it's getting reset here with the 0. That's what's happening. Okay. And this is why it's very useful to think about this as a set of instructions. There we go. Okay, so what have I done here? So for every word in unique words, we need to create its own number system. So when I start with the, I need to have a special counter just for the word the. So I need to do that right here. Then I need to go through every single word on this top line and see if the words match. If the words do match, I add a number, I add 1 to my little counter. And then I print the word and its counter number. Now, once I've done all of these instructions for the word the, I move on to the word time. And then I need to reset my counter back to 0. And you can see there, as I was doing this, I've done this 100 times, but I was still accidentally putting my counter underneath the second set of instructions. So it was constantly resetting my counter back to 0. So if you make these kind of mistakes, it's not because you're bad at programming. It's not because you can't think programmatically. It's because you've just made a simple typographical error. And it's very, very useful just to put in those little print commands after every calculation to make sure it's doing what you think it's doing. And if it's not, to say, oh, have I put this at the wrong part of the instructions? So this little bit of a formula here gives us a very good sense of all the things that we've done today. We've created variables in terms of strings as well as in terms of integers. We've created lists of those strings or those integers. We've used for loops in order to do the same instruction over and over again. And in fact, we've done nested for loops in order to do sets of instructions upon sets of instructions. And we've created a very simple counter. Now, I didn't explain this line very well, and I'm going to do that right now. If you want to add 1 to an existing number, you can do it like this, equals word int plus 1. That's what we would normally do. That's what we've done earlier on in today's lesson. But if you want to do that as sort of a shorthand, add and assign. You can do the same thing with this to subtract and assign so that every time it goes through, it'll decrement or go down 1 number. If you find that this isn't working for you, just go back and do it the other way. There's no harm in just spelling it out. But this is sort of the shorthand way of saying add 1. And it works with any number, obviously, 5, 10, whatever number you want to do. And here we have our simple print command to actually create the list we want. So if I were to use a very much longer piece of text, and that's what we'll be doing tomorrow, we'll be downloading full books as well as longer pieces of text or images. We could go and we could get a simple concordance of all the words that are listed. We could also create different ways of manipulating that text to find out certain information about it. So does anybody have any questions at this stage? Anything that they'd like to see? What we're going to be doing tomorrow, if you're able to join, is to download a text from Project Gutenberg. We are going to manipulate that text so that we can run some textual analysis on it to get more information out rather than how often does that word appear. And we're going to learn how to create some visualizations on it. Now, it doesn't have to be a Project Gutenberg text. So I would like that if you go away and you think about some kind of text or image that is useful in your own research, just make sure that it's in a TXT format, a text file format, or a JPEG or a PNG as your image format. And that way you'll be able to use something that's actually going to be immediately relevant to your own research and your own project. That being said, that was all that I wanted to sort of give you the basic steps. Even if you weren't able to come tomorrow, you now have the basic background on how Python kind of thinks and the basic loops. I worked for about 2.5 years on my PhD with just the functions that you have got today. And I was able to do a significant amount of research just because I was able to process data over and over again without having to do it manually. So I hope you found that useful, and I really look forward to seeing your visualizations tomorrow when we do some text processing. Thank you very much, everyone.